Hello everyone, I'm Nox. I work at Mozilla, and this is my first talk, so I'm sorry if it's going to be bad. So I'm going to talk about stuff I did 2 years ago in 2017. Well, I continue afterwards, but the talk will be in two parts. I will first talk about Stylo, the styling engine in Servo, where we used a lot of Derive code, and the second part, I will be talking about it in the second part. So Stylo is a styling system that was originally in Servo, which is an experimental web engine made by Mozilla in the Rust language. And someone at Mozilla from the Gecko side of things, Gecko is the web engine of Firefox, he was like, they have a nice style engine, even if it's experimental, but maybe we could uplift it in Firefox itself. And you may have heard about it. It's what landed in Firefox Quantum 2 years ago. And so a styling engine in a browser is what takes your DOM tree, so your document, and all the style sheets, and decide that the root of the document should be that wide, this paragraph should be in this color, should have that border, etc., etc. So currently, the style engine in Firefox and Servo has 362 CSS property. So that's a lot of types to represent it. And there are lots of threads to represent concepts in the styling engine, like computing lengths, resolving percentages, animations, serializing of computed values, etc., etc. So there are a lot of threads. So if you see where I'm going with that, when you have hundreds of types and many threads, that's already starting to make many combinations. And so in 2017, when the effort started to uplift it in Firefox, I was added to the project. I started implementing properties, but at some point I started to be angry at doing the same thing over and over. So I asked my manager if I could start working on deriving those implementations instead of writing them. So as an example of a few threads that we have in the styling engine, here are three small threads that we implemented for all the properties. The first one was about, does my value contain a percentage which is relative to the width of the viewport of the browser itself? The second one is the concept of computing values. So when you specify that your length should be 3 EM, the computed value will be represented in pixels, but you still have to keep around a version of your value which was about the EM unit for serialization, developer tools, stuff like this. Every step you need to remember what you did just before for DevTools, exploration, and even the spec. The web is weird. And the third thread was serialization, because obviously you need to print back the values either in JavaScript, again, DevTools, even web pages and whatnot. But it's not all. So when you are doing animations, for example, there are many lengths in the web that should be positive, obviously, like you can't have a negative width. But during animations, the width can become negative because you have some weird curve to represent the animation and stuff like this. So you have the specified value that you wrote in EM, which you compute to a pixel width. But you also have animated values. You also have resolved values, used values. There are like 8 different kinds of values in CSS. And Servo must handle all of them, obviously. You also have animation, as I said. This is what handle interpolations, additions of values, etc., etc., which is represented by this small enum, because Rust is so nice that you can just make new types every time you have a new concept, as opposed to C and C++, as in Gecko. And when you animate a value, sometimes you have to compare it to a 0 state, which may be 0, but sometimes it's not 0, it's 1 when the property is multiplicative, etc., etc., etc. So that like already 7 threads that I cover, 6 threads that I'm going to show you a bit, some implementations and how we derive them. I'm going so fast. So this is what the styling system does currently. Instead of writing a lot of implementations, we implemented Derive macros for all of them. And so the list of Derive is gigantic. And I even removed some of them that were added after I left the Stylo project, because most of them now, I don't know what they are used for, because Servo is gigantic. And many things, like you blink and suddenly there are like thousands of additional lines that you have no idea what it's for, but must be for a reason, I guess. So, no. Yeah. So those are the most interesting traits when you are writing a procedural macro. Proc macro is the one from the Rust upstream standard library. Proc macro 2 is, it's a crate maintained on crates.io, which wraps everything from proc macro for some reason, and I still not sure why to this day. I just know it exists, and that all the other crates use a proc macro 2 type, which is then converted to a proc macro type for the Rust compiler, and it's not very interesting, so I'm not going to cover that. The quote macro is crate is, as usual, if you have done any Lisp, Elixir, or languages with a quote mechanism, it's to write code ASTs as the code in your code, so you can write code while you code, I guess. Syn, if you know about it, is the main parser, Rust parser that lives in userland. It's made by David Tolnay from the Sergi framework. It's pretty robust, and it covers everything in the Rust syntax, and it gets updated very fast when there is a new Rust feature in the language, so that downstream doesn't get blocked because someone on the project wants to use some construct, but your parser doesn't handle it, so your Derive macro crashes and everyone is unhappy. Syn structure and Darling are really the two crates that allowed me to not write code and derive it instead. Syn structure is a crate that was extracted from the Rust parser in Rust-C, and I will show how much it's useful in the next slides. And Darling, same, I'm keeping it for later. So when I started the project, I was like, we have many implementations, and obviously I shouldn't like cover all of them in a single pull request. So I started looking for a good use case that I could show to my manager fast, that it would be really useful if I could focus on that. So I focused on the very first thread that I showed you at the beginning. It's just a single method that returns yes or false or no about whether your value has a viewport percentage in it. And actually, it was so small and self-contained that the thread doesn't even exist anymore in the Servo code base. And I don't know what replaced it. Like, I don't know. So it's a really simple thread. The deriving requires no customization. I didn't implement any Rust attribute that you would decorate your variants in your enum or structures or fields or the type itself. So it was a good first case. And as I will show it later, the boilerplate is entirely covered by Syn structure. It's really, really helpful as a crate. So as an example, here is the implementation of has viewport percentage for a specified operation in your transform CSS property. It represents like when you do a translate animation and things like this. So as you can see, it's just a match on the enum. And for each field, we call as viewport percentage. And if there are multiple fields, we combine them with a logical OR, just as Boolean operation, nothing too surprising. And this is like, there is obviously more boilerplate around these lines of code, but this is a meat of it. Syn structure lets you abstract over struct tuples, enums, everything in a structure type. And then it has convenience methods to do stuff with all the variants at once, and in each variant, all the fields at once. So in this snippet, impute is a type which is, So impute is a type that you are deriving code for, and you pass it to structure new, and you call each variant. It's going to generate code for each variant in your enum. And if you have ever used a fold method in any functional programming language, code false is the initial value. Like if it's just a unit struct, for example, obviously there is no viewport percentage in it because there is nothing in it, so it's false by default. And then you have an accumulator and something that represents a binding to the field in your variant. And you just accumulate more by calling the asViewPort percentage on the new binding, and you combine them with a logical OR, and it's done. This is the entire meat of the code for deriving asViewPort percentage. Again, done entirely with scene structure. Now, serialization is a bit more complex. You have things like separating fields by a space, like in your background property when you say image, a space, another image, etc., etc. And you have things like keywords that were not an issue in the previous thread that I showed. So as an example, this is the background size property, which is being serialized. Again, you match on the enum, you write the width, you write the space, you write the 8, or you write a keyword. So as I was saying, the keyword, for example, we transform them by just lowercasing them and going from camel case to snake case, because every CSS keyword is just a snake case keyword. And then given there is a need to separate them with space, you separate the first from the rest, and you separate them with a space. And that shows a bit more complex example of the quote macro, where you can just write the code and you have interpolation like in Lisp, but it's with a hashtag symbol instead of the comma in Lisp. And again, you just write the code as if you had written it by hand, but with quotation mechanisms. And again, this uses scene structure because it's the only thing that was needed because there was no Rust attributes to decorate the types with, etc., etc. But serialization is more complex than this. Sometimes you have to separate your values by commas instead of spaces. Sometimes it's a function like I showed before for the translate stuff in asViewPort percentage. Sometimes it's a vector values that you have to tell the code that it should be iterated on. Sometimes the iterated field should be skipped because it doesn't pertain to the serialization because it's empty. Sometimes it's a dimension. Dimension is a fancy word that the CSS spec uses to describe units, like 3px is a dimension value. And sometimes you just skip it because the value is here for bookkeeping reasons in Servo and it's not related to the actual CSS spec. And parsing CSS attribute, not CSS, sorry. Parsing Rust attributes is really painful. Like you have to traverse the list of attributes, find the one with the right name, check its contents, check that there are no dupes, check that the name that you have isn't actually relevant to the attribute, etc., etc. And it gets verbose very, very fast. So this is where the final crate of the list I showed earlier comes into play. All this code, which doesn't even fit the slide, can just be replaced by this with Darling. So Darling is a procedural macro that lets you parse Rust attributes in your procedural macros, so you write your procedural macros more easily thanks to other procedural macros. So for example, the function I mentioned earlier, the CSS function attribute, is just a field, and the value represent override is a type provided by Darling, which says if the attribute is present but has no value, it's sum I'm here, and if it has an actual value, it will be sum the value that you passed it to it. And Boolean attributes are just, is the name present in my list of attributes or not? And if it is, it's true, and if it isn't, it's false. And for the keyword, it's just an option, and you have, so option string means the string is mandatory if you put the field. And option override string means that it distinguishes between am I here and am I here with a value, like in pretty much every other framework where we have the notion of am I here and am I here with a value like in Ruby and the nil issues, etc., etc. I'm going so fast. So this is it for the first part. I didn't want to delve too much in details. I just wanted to shout out the two crates that I used. So if you want to add some Derive stuff to your own project, I would suggest not trying to do everything at once, because that's something I do very often, and then I don't manage to do everything at once, so I get frustrated. So don't do that. And use scene structure. Those are GitHub. There should be GitHub URLs, but they didn't fit the slides, so it was bothering me, so I just wrote username / the project. And also, I created an IRC channel on the Mozilla IRC for as long as it's still alive, just because I noticed that I could name channels like they were Rust attributes, so I thought it was cute. So feel free to join it if you have questions about Derive stuff. So now the second part of the talk is about another part of Servo, where, so Servo is a browser, so you have a JavaScript engine in it, an implementation of the document object model. And if you have done some JavaScript on the web before, you know that JavaScript is single-threaded, and there are lots of interfaces in the DOM. And JavaScript needs to access those values all the time. So it's single-threaded, so you want to use ref cells and whatnot if you need interior mutability, and you don't want to have penalty costs for using atomic ref cells or arc when the main consumer will be the script thread, which will run in isolation from everything and nothing else will access values. But one of the cool parts of Servo is that the layout engine is running in, can use multiple thread accounts to do layout of different parts in parallel. And obviously for layout, you need to access the DOM because that's what you are rendering. And now you have a problem because the script thread wants single-threaded access to those data, but your layout really wants to access it from multiple threads. So how do we do this? I wrote a new crate at the beginning of the year called Inert, which does fancy things to, oh yeah, I should have switched already to this slide. So the Inert crate allows you to automatically generate wrappers for your single-threaded data, and the wrapper will be sync, so you will have access to the underlying data from multiple thread accounts in a controlled fashion. And the only unsafety that you have to maintain is you have to promise that when the wrapper is alive, you are not accessing the underlying data through other means. And that doesn't sound very different from doing it without this crate, but the main advantage is that the unsafety will be localized to where you are making the promise to not access the underlying data. So for example, in Servo, whenever layout is running, script is waiting on a channel for a reply from layout. And obviously, when you are waiting on a channel, you are not doing anything else, so you are not accessing the data. And on the layout side, given you have these fancy wrappers with accessor methods that are automatically generated, you don't need to write unsafe code by hand, so you are sure you didn't fail to write this unsafe code. So Inert just comes with this minimal API where there is an inert wrapper around your t value, which you can instantiate unsafely with the new unchecked method. And it's just a dirty pointer cast. I love this trick. Like you write a new type wrapper around the data that interests you, and you pointer cast a reference of your underlying data to a reference of the new type wrapper. And this type derives to a T output, which is implemented in the neutralize unsafe threat that I will show in the next slide, I think. Where is it? Well, I will just describe it. So the neutralize unsafe threat is just a threat with an associated type and a neutralize unsafe method. And so your T type is the single threaded type that you can't access from multiple thread attempts, and the T output must be sync. And this is what the layout thread access indirectly instead of just going into the underlying data. So how does it work in practice? This is not interesting. Yeah, so what did I do? I think this morning I deleted the slides and that was a mistake. Yeah, so I will just describe it. So this is the output of the Inert procedural macro, and I deleted the slide where I was using it. So it's going to be a bit complicated to follow. But so you have a node type, and you can decorate it with a neutralize macro, and you annotate the fields that interest you, and for each field it will generate an accessor for this field, which will return itself a wrapped neutralized reference around the field itself, and it gives complicated types, but remember this inert vec refcell node. Yeah, so a ref cell is neutralized by returning an inert ref cell, which is, again, just a wrapper around the ref cell. And it comes with this method that calls ref cell try, borrow, and guarded, which is something that I landed in Rust 2 months ago, which is just like try, borrow, but when it succeeds, because the underlying value was not currently mutably borrowed, it returns a reference to the inner value without actually changing the borrow flag of the ref cell, which is why it's unsafe. And if you remember what I said at the beginning of the second part of the talk, it was that the layout thread must access the data, but without mutating it ever. And when the wrapper exists, anything else shouldn't be accessing the data directly. So anything else shouldn't be touching the borrow flag of the ref cell. So all you have to care when you are accessing the ref cell from the layer thread is that the ref cell wasn't mutably borrowed before you spawned the layout operation. So try, borrow, and guarded just lets you do this. It lets you return a reference to the underlying data as long as it wasn't mutably borrowed, but you can still mutably borrow just afterwards, but it will be undefined behavior. And for the inert vec ref cell node type that I showed earlier, so vec ref cell node is neutralized unsafe. So inert vec ref cell node derives to a slice of inert ref cell node, and node is neutralized unsafe. So inert ref cell node derives to inert ref cell inert node, and the inert node that you can access by calling inert ref cell borrow derives to inert node, which is a wrapper that was generated by the procedural macro with the getters that were also generated and which contains unsafe code that you don't need to write yourself. Voila. And I guess that's it. Sorry for the deleted slide because that messed with my brain. You can contact me on Twitter, Mozilla IRC, rest in peace, LinkedIn, mail, cafes, and GitHub, but that's work. That's it. Any questions?
Hi.
Hello.
Do you have a rough estimate of the lines of code you spared by doing all this stuff? So before and after the cure.
So I joined the project midway, but so I prevented thousands of lines from being written. And in my pull request to Derive, I think I removed 4,000 lines of code, which was nice.
4,000?
Yeah.
Okay.
And I actually found bugs. Like missing spaces between fields, keywords which were not actually serialized correctly because there was a typo in the name, and things like this. It was pretty cool. No other question?
Any other? Okay, thank you again. Thank you.